talked about our variables, and we said they can be qualitative or quantitative. Qualitative deals with a characteristic, quantitative deals with a number. I did kind of warn you that you can't just automatically, as soon as you see a number, assume quantitative. It has to have a numerical meaning, but that is something to keep in mind. So let's go through each of these and decide. Nationality. Is that qualitative or quantitative? Qualitative. So this is in your example packet. Number of children. Household income in the previous year. Quantitative. Level of education. So that's like saying high school, associates, bachelor's, master's, doctorate. Daily intake of whole grains measured in grams per day. Okay. I'm going to talk about one more thing, and then we're going to do a little practice with this. Well, maybe two things. In the quantitative variables, so when we're dealing with those numbers, we can have different categories here, discrete and continuous. So we're back to your terms page. Sorry, I know it's annoying going back and forth, but I promise, look, if you have to look back at something, it's easier when it's organized like this. So if it's quantitative, there are discrete and continuous variables. Discrete, if you want to summarize, it really just means countable. If you can list out all the numbers, it's discrete. If I'm counting how many apples are in my refrigerator, that's discrete. I can count that. Continuous is exactly what it says. It has an infinite number of possible values. If I'm talking about the weight of something, that's actually continuous. Why? And like, does something just weigh 50 pounds? Exactly. Can it be 50.1 or 50.01 or 50.0001? If you have all those decimal possibilities, that's going to make it continuous. If it's something you could list out the options, that's discrete. So if we look back at that example we just did, example 4, we had 3 of those that were quantitative variables. So on your example 5 slide, I took those 3 quantitative variables, and we can identify if those are discrete or continuous. So, number of children, is that discrete or continuous? Discrete. That is countable. We can list that out. Household income the previous year. So income, money, it has decimals. Does it have an infinite number of decimals? No. Money only goes to the nearest cent. So could you list every possible value? Yeah, we probably don't want to. It's annoying, but we could. So it is discrete because there are a fixed number of decimal places. We can only have 2 decimal places in that. Now when I'm looking at grams per day of your whole grains, can you have a decimal or a fraction there? Yes. Do we have to round that to 1 or 2 decimal places? No, we could round that to as many as we wanted. So what would that one be? Continuous. Next example, and I apologize, this is really hard to read. So I want to identify, and it's up to you if you write all this down. I just want to kind of take some data and pick out the pieces. So if you can't read it very well, I know it's a little difficult. It has country, and it has several countries listed. It has their government type, the life expectancy in years, and the population in millions. What would the individuals be here? I'm sorry, I'm not asking just like qualitative or quantitative. I want to know like what would be an individual in this. Yes, each country. You don't have to list them out, just. And is that qualitative or quantitative? Yeah, that would be qualitative. Okay. What are the variables? For each country, what am I concerned with? Life expectancy is one.
Government type.
Government type.
And the population.
And population. 3 things that we're looking at. Life expectancy, is that qualitative or quantitative? Government type?
Quantitative.
Population. Okay. For the quantitative ones, we could do discrete or continuous. Life expectancy. Now, in this table, it said years, and it did round to 2 decimal places. Are we limited to that? No, we could give life expectancy to the nearest year, to the nearest month, to the nearest day, to the nearest hour, to the nearest minute, to the nearest, you get the idea? So this one would be continuous. Anything dealing with time is typically continuous. Just like weight is typically continuous. Population. It's listed in millions, so it has like 22.5 million, 34.8 million. Would this be discrete or continuous? Discrete. Population is talking about the number of people. Okay, you can count the number of people. Given enough time, you could do it. So that would be a discrete variable. All right. Last thing in this section, and this is probably the most tricky piece, and it's a little bit subjective, not always clearly cut and dry. There are different levels of measurement. So we'll talk about this a little bit. It is not going to be a huge emphasis of mine because of the reason that some of them are very obvious, but some of them you can make an argument it's not always easy to define. But this is on our terms page. So when I am looking at, do you want me to give you a second to write before I start talking? There's a lot of terms up here. There's 4 terms, so you can write the definition. I put some examples, it's up to you if you write the examples. I'll give you a few minutes and I'll talk about it. Okay. So this is the piece that gets a little tricky. The levels of measurement. So nominal data, basically all we can do with it is categorize it. We can't rank it in any type of order. If I ask your gender, okay, male, female, is there any way to rank that and say, well, this one should come first and then this one comes after that? No. If I'm talking about your eye color, brown eyes aren't better than blue eyes. There's no way to put those in a meaningful order. So if all you can do is break them into categories, that's nominal. Okay, we always start there. Everything is at least nominal. And then we go to the next step and say, okay, is it also this? So the next step would be ordinal. So we still have our categories, but we could rank it. So if I said like freshman, sophomore, junior, senior, can we put those in a meaningful order? Yes. You know, we can put them, well, freshmen, they're 9th grade, 10th grade, 11th grade, so that makes sense to put them in an order. You know, class officers, it makes sense to have an order with those things. Do you see the difference between nominal and ordinal so far? Okay, so the next step, if it's ordinal, we have to check, can it be interval? So, it's still categorized, it's still ranked, but I add an extra step, evenly spaced. Okay, so if I'm talking about class officers, does it make any sense to say there's the same amount of space between president and vice president as vice president and secretary? No, that has no meaning whatsoever. But if I'm talking about the temperature outside, okay, so there's the same difference between 77 and 78 degrees as there is between 78 and 79, and 79 and 80. So we categorize it, we can rank it, but if it's the same distance between every group, then that also makes it interval. So like your test scores, your percentages, there's the same difference between all of them. Things dealing with money, same difference between them. Ratio has all of these, categorized, ranked, evenly spaced. I add in one more piece. It has a natural zero. Okay, does temperature have a natural zero, a stopping point? No, because it could go below that. Okay, so it wouldn't make sense to say it's ratio. Height, does height have a stopping point? Yeah, you can't be a negative height, that wouldn't make sense. Age, weight, those kinds of things. If it has a clear zero, a beginning point, then it is also ratio data. So here's what we're going to do. This is not for a grade, so don't stress out. It's just practice and kind of giving us a conversation starter. So if you would go to Google Classroom, I posted a Google form here, and I want you to try to fill this out. Okay, so take a few minutes, answer these questions. It's kind of going over all the different things that we've done. Qualitative, quantitative, discrete, continuous, and these levels of measure. So I believe this is our last example for the section, so example 7 on your packet. So a study was conducted to assess school eating patterns in high schools in the U.S. So we analyzed the impact of vending machines and school policies on student food consumption. We have 1,088 students in 20 schools. I want to know the level of measurement of each variable. So I gave you a ton of background, but all I'm really doing is categorizing these variables. Okay, nominal, ordinal, interval, ratio. Number of snack and soft drink vending machines in the school. So we know it's at least nominal. Can you put that in an order? Yeah, 0, 1, 2. So that takes it up past ordinal. Interval. Is there an equal distance between all those numbers? Is the same distance between 0 and 1 as 1 and 2? Yes. Yes. Is there a meaningful 0? Yes. So this will be ratio. Whether or not the school has a closed campus policy during lunch. So this is like a yes-no question. Nominal. We can categorize it, but can I rank those? No. Okay, I already used this example. Class rank, what would that be? Ordinal. We can put them in order, but in order to be interval or ratio, it really needs to be numerical data. I can't say there's the same distance between different things. Number of days per week a student eats school lunch. Ratio. Could it be 0 days? Absolutely. Okay. So the rest of the class, I have an assignment for you to work on. Most of these are one-word answers. You're saying like discrete, continuous, quantitative, qualitative. There is an answer key, like always, for you to check if you get done. Advisory, we will all be in the cafeteria, so I'll bring my folder down there in case you want to check it during advisory. And you've got the rest of the hour, do it in pencil, sheet of paper you can turn in. I don't mind if you ask